Water does not run uphill. Every child learns this. Every engineer confirms it. Every pump ever built in the history of humanity draws on an outside source of power, a motor, a windmill, a hand, to move water against gravity. Except one. There is a device that takes water from a stream and pushes it uphill to a tank, a trough, or a house. Day and night, without stopping. For decades. Without a single electrical connection, without a drop of fuel, without anyone watching. It has exactly 2 moving parts. Both are cheap valves. The entire mechanism fits in your hands. In 1798, the people of Portsmouth, New Hampshire, watched one run in their town water system and gave it a name that perfectly captured what they were witnessing. They called it the Perpetual Pump. Newspapers reported that it worked by day and by night, at all times and in all seasons. A barrel of water every minute, endlessly, powered by nothing but gravity and a column of flowing water. And then, within a century, the modern world forgot it existed. To understand the pump, you must first understand the man who invented it. Joseph-Michel Montgolfier was born in 1740, the 12th child of a French papermaker. His family described him as a restless dreamer, a man who stared at fires while everyone else went to bed. One evening in 1782, he sat watching smoke curl toward the ceiling and asked himself a question that would change the world. What if a bag could be made large enough to catch that rising force and carry a man into the sky? He built it. On June 4th, 1783, Joseph and his brother Etienne launched the first hot air balloon ever to fly. The crowd went silent, then erupted. The balloon rose to 3,000 feet and traveled over a mile. Europe was transfixed. But Joseph quietly went back to his paper mill. He had a much more practical problem to solve. The mill needed water. The river ran below in the valley, but the papermaking happened up above. He stared at the water the way he had stared at the fire. He noticed something most people walked past every day. When flowing water is suddenly stopped by a shut valve or a clenched pipe, the momentum of that moving mass does not simply disappear, it converts. It becomes a pressure spike so intense that it travels back through the pipe like a shock wave. Plumbers called it water hammer. They considered it a nuisance to be solved. Joseph Montgolfier called it an engine. In 1796, he built the world's first self-acting hydraulic ram, a device that weaponized the shockwave of a water hammer to push a portion of that water higher than it had any right to go, powered entirely by the weight of the water falling below it. No electricity, no wind, no hands. The same mind that sent men into the sky had found a way to make water climb. Word traveled fast. Robert Fulton, the man who would later build the first practical steamboat, wrote a letter in February of 1798. He had seen the device running in Paris. He described a means of raising water from the beds of rivers by the simple movement of the stream without either pump or wheel. 40 feet high, 2 tubes, extremely simple. Matthew Boulton, the man who partnered with James Watt to build the steam engine, took out a British patent on Montgolfier's behalf. The greatest industrial engineer of the age was protecting the invention of a papermaker who built balloons. Thomas Jefferson read about it and wanted one at Monticello. He wrote about it in 1805, noting that the president of a new nation recognized the power of a pump that needed nothing from anyone. By the late 1800s, hydraulic rams were everywhere. An engineering firm run by Josiah Easton supplied them to country houses, farms, and entire village water systems across the British Empire. One such installation went into a grand estate in Cornwall called Heligan in 1880. 3 ram pumps, buried in an underground stone chamber, pushed water continuously uphill to a 40,000-gallon reservoir. They ran for over 80 years without stopping. Click, clack. Day and night. Season after season. In America, a settler named William Priestley stood on the edge of the Snake River Canyon in Idaho, needing water for his farmland 110 feet above. He built a hydraulic ram from boilerplate and pipe fittings, pushing water straight up to his crops using nothing but the pressure of falling springs. It worked so reliably, so elegantly, that the United States government eventually declared it a National Historic Landmark. It still stands. And then, electricity arrived. The erasure of the ram pump did not happen with sabotage or a corporate ban. It was quieter, and in some ways more complete. The electric pump was faster and easier to install. You plugged it in and it worked anywhere. Rural electrification spread across America, and a whole generation of mechanical wisdom was simply set aside. Not burned, just forgotten. But that simplicity was an illusion. The electric pump depends on a grid. The grid depends on utility companies, monthly bills, supply chains, and a system that can, and does, fail. The hydraulic ram depends on gravity. Gravity has never had a billing department. By the 1960s, a technology that had supplied water to an empire had been reduced to an afterthought. The Eastern Company, which once sold thousands of pumps a year to estates and villages across England, had shrunk to annual sales of just £1,500. Then, in 1990, a record producer named Tim Smith was clearing the overgrown, abandoned gardens of the Heligan estate in Cornwall. 18 feet underground, his crew found a stone doorway sealed with a century of mud. When they cleared it, they discovered the ram chamber. Inside were the 3 Eastern hydraulic ram pumps installed in 1880, perfectly intact. The valves still seated, the chambers still sealed. By 1994, the pipes were renewed and the century-old rams were overhauled. They were started and they ran. After more than 70 years of silence, the Victorian pumps pushed water back into the stone reservoir 24 hours a day, without a single kilowatt of power. Click, clack. The same sound that had echoed through that chamber in 1880 filled it again. So how does it actually work? And more importantly, how do you build one? The mechanism is almost insultingly simple. Flowing water enters a drive pipe and runs downhill toward the pump. It picks up speed, rushing faster and faster, until it escapes through a weighted valve at the bottom called the waste valve. As the water accelerates out, the drag becomes great enough to snap that valve shut. That sudden shutdown of moving water creates a massive pressure spike, the water hammer. That shockwave forces open a second valve, driving a portion of the water up a delivery pipe much higher than the source it came from. The shockwave passes, the second valve closes, the waste valve falls open again, and the cycle restarts. Click, clack, between 20 and 100 times a minute, every day, every year. To install one, you need 3 things: a water source that flows at least 2 to 3 gallons per minute continuously, a drop in elevation of at least 3 feet from the source to the pump, and a destination where you want the water delivered. The efficiency is staggering. For every 1 foot of fall from the source to the pump, a properly installed ram can lift water roughly 7 to 10 feet. With an 8-foot fall, you can push water 80 feet uphill. A modest stream with a 6-foot drop can deliver nearly 3,000 gallons of water per day to a tank on a hillside above your house. That is enough drinking water and irrigation for an entire off-grid homestead, running continuously without asking anything of anyone. The trade-off is volume. The pump delivers between 10 and 30% of the water that drives it, while the rest spills harmlessly back into the stream. But that smaller volume pumps continuously, around the clock, every day of the year. You can build one yourself from basic plumbing parts: a rigid drive pipe, a brass waste valve, a delivery check valve, and a pressure vessel made from a capped piece of PVC pipe, with a bicycle inner tube inside to cushion the shockwave. Clemson University and North Carolina State agricultural engineers have documented the full build. Total parts cost under $200. No permits required in most jurisdictions, because you are simply managing surface water on your own land. This brings us to the question that matters most. The same man who launched the first balloon, who showed humanity it could defy gravity and leave the ground, also invented a device that uses gravity to move water uphill forever. He gave us two gifts in 13 years. One took humanity into the sky, the other kept it alive on the ground. We remember the balloon. We teach it in schools, name airports after the Montgolfiers, celebrate the age of flight. But the pump, which has moved more water and kept more communities alive than any balloon ever could, we quietly forgot. This is the pattern. The knowledge that must be purchased, metered, and maintained by a corporation gets preserved. The knowledge that requires nothing from anyone except gravity and ingenuity gets set aside. You cannot sell electricity to a ram pump. You cannot bill its owner monthly. So it faded from agricultural schools, from engineering curricula, from the catalogue of things worth knowing. Meanwhile, the grids that replaced it are failing. Communities that built their entire survival around electric pumps are discovering what happens when the power goes out and the backup generator runs out of diesel. But somewhere in a forgotten valley, a hydraulic ram pump is still thumping. Click, clack, day and night, at all times and in all seasons. Down in a stone chamber at Heligan, out on a hillside in Idaho, in the creeks and streams of anyone willing to look. Joseph Montgolfier gave us two things: the sky, and a way to survive without asking anything from anyone. We kept the sky. The pump waited. It is still waiting. If this vault opened something for you, if you can hear that click and clack on your land 10 years from now, subscribe to Nature's Lost Vault and hit the bell. Every like and every share keeps this knowledge alive. The next vault opens soon.